Hello and welcome to this demo video showcasing my Wildfire Risk Predictions machine learning project. The inspiration for this project was my desire to leverage AI to address the issues of wildfires and their repercussions. Wildfires have become more frequent and destructive in the past years across the U.S. And every year they now cost billions of dollars in damage and endanger many communities. If we could anticipate fires and estimate their spread, we could significantly mitigate their harm. And that's the idea behind this project, predicting a hazard risk score calculated by multiplying the probability of the fire ignition times the predicted burn area. So how the model works is that it is a combination of two models. The first model predicts the probability of fire ignition, and the second model predicts the burned area. And when combined, we can multiply these two values to find the hazard risk score. And this score reflects the expected impact of a wildfire. And agencies can use these to prioritize any high-risk regions and plan more effectively for those and prioritize them. The model data set has satellite data from NASA's MODIS instruments, and those provide daily images of the U.S. And these images are fed into a deep learning model, which then pick up patterns like vegetation dryness and landscape features. We combine these features extracted from the deep learning model, and we combine them with climate conditions such as temperature, humidity, wind speed. And then we feed this data into the two models, and combined they will predict the hazard risk score. And now I have a demo showing how the model works. So if I just run this script, this script randomly samples one observation from the test set, and it prints out the statistics. So here we have a sample number 321. The model predictions, the P model prediction is probability ignition of 0.28, so 28% chance of being ignited. And then the A model predicts an expected burn area of 3 hectares. And so there's low risk because there's a low chance of fire ignition, and the expected burn area is really low. And here are the actual values: no ignition, and the actual burn area was 0 because there was no ignition. So here we can see that it's fairly accurate in the hazard score, which is pretty close to the predicted actual burn area. So over on the GitHub, we can view the evaluation metrics for the model, and it first lists out the individual evaluation metrics for each model. But more importantly, let's take a look at the combined model that predicts the hazard risk score. And we can see that the root mean squared error and the mean absolute error are still rather high. But despite that, there's still value in this model because it can at least predict the relative severity of wildfire risks in certain regions in the United States. That's shown by a rather high Spearman correlation. And so the model can still help support fire departments by way of helping devote more resources to regions of higher wildfire risk, and reducing response time by giving more time to prepare before there's actually a wildfire occurring.